So, first talk of the afternoon. Everybody's probably still feeling a bit drowsy from lunch. So I'm going to start you easy with a small trip back in time to a much simpler time. As we write 2015, HB2 has just been standardized and everybody is very optimistic. I just love this headline. It's the best thing since 1999. And it's
1999.
What?
1.1 or?
I think so, yeah. So the best thing since 1999, and this is also the year that I started my research. And there was about 1 week in 2015 that I was so delightfully naive that I actually thought that I was the first person in the world to discover TCP head-of-line blocking. True story. But so after that, I quickly got interested into the pitfalls of HB2 and how things are now actually put on the wire in this new multiplexed situation. It turns out it was quite difficult to understand because the main sources for that are whatever Chrome would give us or the Wireshark traces. These things are usable, but they can get quite tedious quite fast. And so we quickly switched to more visual style of debugging. For example, here it's again a timeline view where you have each row is an individual resource, an individual stream, and all of the squares are individual frames on those streams. You can very clearly see that the first image here gets a little bit of bandwidth, then the second one gets bandwidth, the third one all the way down, then it goes back up again, we go all the way down again, and then the biggest resource gets all its bandwidth. This is because of HB2 prioritization, and this is using a round-robin scheme where all of the resources get the same amount of weight. That's one of the simplest schemes. These trees can actually get quite complex. So we also built a timeline priority tree visualizer, and for example, this is a Firefox setup, which is already quite a lot more complicated. Using these tools, we were able to assess implementation details and also find quite a few high-impact bugs. This was about 1.5 years ago, and so about a month ago, I think, these things also started to show up in Pagetest. If you don't know Pagetest, it's a free online tool that you can use to assess your page load performance. And they now also added opaque bits in their waterfalls. So the opaque parts are actually where the HB2 data is arriving. They also have a simple priority tree view. And this has caused people like Andy Davis here to start looking into differences. These are both Firefox, and yet the right one seems to be loading much faster. It should be better for user experience. And the only difference here is actually just what happens on the server side. It has to do with TCP buffering, with load balancers, upstream, caches, that kind of stuff. Which turns out to be quite difficult to debug, as we don't really have much information on what's happening on the server side at this point. So that's kind of what we are at with HB2. As we all know, QUIC is probably going to turn out to be way, way worse. It's, of course, a lot more complex, because we know also what to do to transport stuff. We also have to re-implement most of these things from scratch. So there's a high probability of bugs and unwanted or unexpected behavior. And we actually started making our own QUIC implementation. It's called QUIC. To be able to debug that and the other open source implementations, we quickly created new visualizations for QUIC then. So here again, the known timeline. Where you have the connection level view on top and then split out per individual stream. This, at first glance, the bandwidth distribution between the streams looks a lot like the round-robin prioritization from before. It's actually not, and I'll go into detail about why that is later. So this is the timeline. The second one is the sequence diagram, which seems a bit simple. But if you compare this to what you typically get from tools like TCP trace, you see that here you have a lot of overlapping data, and most of the lines are running almost horizontal. That's because you here don't really have good latency information. You don't know when the packet was sent and when it was arrived. So what we're trying to do is combine client and server-side logs at the same time, so we can correlate based on packet number. We know exactly when a packet was sent, when it was arrived, so we know exactly what the network latency is versus the application latency for each packet. This allows some other really cool things as well. For example, we visually see reordering happening if you have lines that are crossing. you can very accurately detect lost packets if you don't see them in the trace of the other side. And crucially, also retransmitted packets. That's quite difficult at QUIC. Just a second. That's quite difficult at the QUIC level normally because QUIC can retransmit frames in different packets. They can redistribute it over new packets, and it doesn't reuse packet numbers like TCP does. So you really need some extra information to be able to do that reliably. That was a question.
Yeah, does the combination require clock synchronization between client and server?
To get best results, yes. At the moment we bypass that, but so that you can offset the clock manually for the 2 frame. But ideally, you would have the same clock exactly. So you can do that, and we also log things like congestion control state when it is updated whenever an acknowledgement is received. You see here we really rely a lot on these logs, and to be able to do that we have to go and parse the logs from the different open source implementations. As it turns out, this is much more easier said than done. For example, our own implementation is very, very verbose. I like a lot of logging. For example, we are one of the few implementations that actually logs the TLS keys, which I wouldn't recommend in a production level environment, but it's quite handy to have in a debug context. If we compare that to NGTCP2, it's a much, much more terse format. They also use a lot of shorthand, as you can see on the right top side. For example, the RECV on the top, that means receive. RX means receive. And RCV, obviously, means recovery. Duh. And I can already see Lars sweating a bit, because he has that kind of thing as well in Quant. Connect opening. But the main problem with Quant was that it uses a HTML-based format, so yay, let's add another parser.
It uses NZ color.
NZ, yeah, true.
You can grab them out.
But so, that's not really the point. The point is it's doable, but it's a lot of work. You have to do a lot of work, and especially now in the constantly evolving stage. It was a huge amount of work to keep this updated to new versions. That's why we're also just stuck with draft 11 traces in this presentation, because it was just too much to do all the draft 12 and 13 stuff. So while these logs do have most of the information in them, we did find some things lacking, especially at the flow control and congestion control level, and also at the retransmit based. For example, there was one thing that where QUIC was actually retransmitting data, but in overlapping segments, which was not that easy to deal with. I expect this to be worse for the HB3 layer, as you do get things like the prioritization stuff coming in on this. So then we started thinking, how about we make it easy on ourselves and make everybody use a standardized format? The goals for this initially were mainly to have something that is easily parsable, automatable, but also that a human can just understand these textual logs, which is not always the case with the current implementations. So what we have here is mostly a strawman approach. I'm not really suggesting that this should be the final logging format. We're using JSON because it's very easy to build web-based tools on that can easily be shared. It's actually a very simple format where we have a lot of metadata per event, so we have things like category type. So it's easy to filter. If you're not interested in any HTTP layer stuff, you just filter out the full category, or you just don't log it. You get the logs that you want. One of the main things that we added is the fourth column, the trigger, that I also mentioned before. Because, for example, on top you see if you have a stream open, that can happen, for example, due to a HTTP GET or an HTTP push, and that's, of course, a very important distinction to make. Also on the bottom, like I said before, you have many different reasons why you want to resend a packet, and you really want to know which one of them it was in context. So let's try and see if we can interpret this, because one of the goals, like I said, was to be understandable without even having to use a tool. So here on the top we receive a new packet. It's got a GET request for ping.html. On the HTTP level we open a new stream for this one. We then create a new stream frame to get the reply of POM sent in there in frame number 16. That is then put into a new packet. number 67. We try to send a packet, but we don't have congestion control allowance, so we have to queue it until sometime later when we receive a new acknowledgement. The congestion window is updated, and we can now finally flush the queue and send the original packet. Once again, I don't think the real log would look exactly like this. I left out quite a few things, but it kind of displays the concept where we're coming from. As luck would have it, about 2 days after we sent this in for review for EPIQ, the Google guys posted something on the mailing list, something very similar. Quicktrace or Quicktrace, I'm not sure. I think it was Quicktrace. They don't use JSON, but they use protocol buffers. They also focus very heavily on congestion control, and they have simple visualizations as well. What I found interesting in their format as well is that you see again the concept of events and also reasons why these events happen. And so there are very, very noticeable similarities between these two completely disjoint approaches. And so I think it's a very clear indication that Google should hire me. Or, of course, that this is an important part to take along in a new logging format. So let's say we have finally a new standardized logging format. I don't really care what it looks like as long as it's there. We also want a standard way to access it. So you had this very similar thing in HB2 where they used the well-known URL that you can see here. The downside I thought was that they only allow you to fetch the logs for one connection, the connection you're currently on. What I would like to do is extend this and then also give you a way to list all of the connections that are currently on the server, so you can just fetch them all in one go, for example. I would also extend this to the browser, so that we have a very clean API on the browser side as well. This is mainly interesting again for tools like Pagetest or any type of other automation. You can just run your tests, fetch the logs in one go afterwards, in a very simple, straightforward manner. I can, I can see that some people, more security-minded people in the audience might start to sweat a little, especially on that /list URL. So of course, we need to think about security as well. And I'm not a security expert, but, famous last words, but I think there are plenty of different ways that we can approach this that is more than safe enough to be usable. For example, you could add a token that needs to be present if you do request for these connections. If you set the token on the server config, any on-path attacker won't have it. You could go with an ephemeral token for each individual connection. You can encrypt the logs themselves. Like I said, I'm very open to feedback on this approach. The main thing I think we need, if we allow this kind of thing, is we need sensible defaults on all the server implementations, so that you don't have an accidental foot gun. You don't want to be logging your TLS keys by accident. So the main flow setup that I envision is you have a single format used by all servers and the browsers as well. So it's very easy to aggregate into a single database, do analysis on it, then create reusable tools on top of that. And then you can share not only the data, but also the tools with other people, so that you have a lot less extra work going on, and we can cooperate all better. All right, so just have a couple of examples of the things that we found when developing and using these tools. So what we did, we also implemented a couple of conformance tests. Nothing as extensive as the next presentation, don't worry, Maxime. But so for example, here it's a test where we just shut off the connection for a while in the middle of the trace, and then look how the implementation responds when it comes back online. And what you expect is actually the top one, that's a well-behaved one. You get some retransmits, but it's with a back-off timer. So you have, let's say, 100 milliseconds, and 200, and 400, and 600, something like that. That's what you would expect. The bottom one is what you don't expect. This one just keeps on resending at the constant timer. And what you see there at number 3 is apparently this implementation kept on buffering all data. Even if the network was down, it was still trying to send, filling internal buffers. The network comes back on, tries to send everything at the same time, is immediately flow control blocked, and then just starts spamming massive amounts of flow control blocked and max stream data streams. It should be no surprise that the bottom implementation was our own. So we're very happy to find and fix this bug. The second bug is actually one of my favorite bugs that I found ever. The QUIC disallows duplicate packet numbers. It's not a very big deal. You're supposed to just drop a duplicate packet if you receive it. What this implementation did was it saw the first packet, responded to it in full, so you get the full requested HTTP resource for that stream. Then suddenly it notices, oh no, I received a duplicate packet number. This was a protocol violation. Apparently, it sends a connection close 4 times using the exact same packet number for its own connection closes. How's that for irony? Lots of fun. The next one isn't really a bug. It's more something that we came across, is that it was sometimes very difficult to identify if something is blocked from sending. Is it based on flow control or congestion control? As these can have quite complex interactions. And so this here on top, we log the flow control allowances per individual stream. And then also the data that is sent for that stream. So on the left side, quick people, is actually the offset for that stream. So if you have overlapping data on the y-axis, which happens at the letter R here, that actually means a retransmit for that amount of data. And here you see that we have 5 streams, and streams 16 and 20, so the purple and the brown one, are actually delayed. They can't be sent at the first time, even though they have enough flow control allowance. So we have to drill deeper and go to the bottom part, and there we also plot the congestion control information. And there we can clearly see that the congestion control window only allowed up to the first 3 streams to send their flow control limits. Then there is no more data allowance. Then we finally receive some acknowledgements. That's number D. Flow control window, congestion control window goes up. We suddenly do have space to send the extra stream data. So this actually then maps back to the one I showed you before. This looked like HB2 round-robin prioritization, but was actually just this complex interaction of flow control and congestion control happening, where one of the two is blocked. Going in. So it's sometimes very interesting to combine multiple visualizations on the same data to get deeper insight. That looks quite simple, but this really only starts to shine when you do have a little bit of loss. What you can see here is very clearly that the moment most loss happens, it starts to diminish, of course, the congestion window by about half. Those are all the H's on the bottom graph. And you see the effect that had on the 2 later streams at the letter L. They've been delayed significantly more than maybe was the intent, right? Depending on what your application is, you might want to send a little bit of stream 20 and 16 at the front as well, instead of giving the first few priority. So this is going to get just worse with HB3 prioritization, of course. So you really, really need something to visualize these interactions. So it's time for a conclusion. We found that combining logs from different viewpoints, as opposed to just using a single trace, is very, very useful. It would be really nice if you could have a standardized or de facto standardized logging format, especially for the people that are writing the tools. But the main thing I want to do is say let's start thinking about quick debuggability now, before V1 hits the shelves, or else we will be 3 years in waiting, just like it was with HB2, until we get some thing going on. And I want to prevent that for QUIC. So almost none of what I said today is something that I think should be deployed as is. We're very, very open for feedback and how this might be done in practice, how people are willing to support it. For example, for QLog, we were thinking about providing a low-level C library to make it easier to integrate. I'm not really sure if that's a good idea or if anybody is interested in something like that. So Feedback like that, feedback on the security aspects, feedback on what other types of visualizations would be useful is very, very welcome. That was a perfect 20 minutes. So, thank you for your attention.
So yeah, we do need something like that. I think the details I think are not so important, but the question is sort of would people actually implement this, and if so, right, how, right? Do you, for example, do you envision that the logs, would they be available at the various URLs or in whatever format they become available as a connection is still alive, or do you think this will be post-mortem, or?
For our use case, post-mortem is more than fine, but...
Post-mortem is easier, obviously. Also
exactly,
in general,
yeah.
Okay.
I think most use cases would be post-mortem good enough. But it's nice, JSON can be streamed, so you could envision it.
And this has the usual platform problem that you have a bunch of implementation, one person comes up and says, oh, we should do this, and so everybody says, oh, but implement something else. So you spoke quite a bit about simplification, so is any thoughts on minimal hooks that would need to go in, and who would be the right person or entity to provide those hooks to look into? So I think you're probably, the proposal you have up there is probably going a bit too far, but heading the direction, I agree, would be in that direction could be useful. The question is, how can you do this without scaring people away? Do you have any thoughts on that?
No, that's why I'm here.
Scare people. Okay.
It's like one of the things that happened with the Google Suggest proposal. They put it on a mailing list. It got about, let's say, 10 replies, 9 out of which were about, we don't like protocol buffers. It was not about, oh, this is cool, we need a debugging tool. No, it was, the format is not what we want. So I'm very hesitant to suggest a JSON-based approach. And indeed, that's the biggest hurdle for me, is to know if implementers are willing to do something like this and the effort that they're willing to put into this. I personally put QLog in several implementations. It was actually quite alright to do without a library or something, but people still need to want to support this. So if you're watching this on YouTube, I think you are.
I have a couple of questions for you. So whenever we are building a stack, it does make sense to be able to debug it at the point where it's being built. But then there is also a need to debug it at the point after it's deployed. Do you have a sense of what this might look like? Like, some customer providing feedback on how well QUIC works or doesn't work. Do you see an aspect of this come out without, is it useful without having all the crypto keys available?
It's useful without having the crypto keys. I think if the logs are just plain text, that you can just fetch them plain text.
No, if you cannot decrypt the entire header, but you can only see part of your header.
I think that's one of the main problems with QUIC, is that it's so closed off that you can't really make anything if you don't have the decryption key. So I might be wrong, but I don't think that would be very valuable. Yeah, the second question.
And do you see this being, like, what tools do you see this being deployed?
Everything. I would hope, like, the point of the JSON and making it easily filterable is that you would have different versions of what you see. Like, for example, I would envision a really production level deployment to do very little of this. We're doing congestion control experiments, so we're only logging congestion control information. What I would like to envision as well is that big parties like, let's say, a CDN, that they deploy their literal production level code, but on like a separate server that does full logging, so people can use their clients and see what is the Cloudflare implementation doing, for example. Of course, not in production, but having the same implementation running, and that you can test against the exact same code base, even if it's not open source. I would really like to see something like that.
But would I integrate this with a Wireshark, or would it be integrated with each of the browsers? Where do you see this?
We thought about doing a Wireshark implementation, but it's just so much easier to do a browser-based tooling. You have so many JavaScript libraries that help you with visualizing this kind of stuff. I literally added one of these visualizations in about a week from scratch, so it's very easy to iterate on JavaScript. I would really prefer it to be browser-based, but then you have the issue of debugging very large traces. That's one of the comments that I got on the paper, is like, if you have a very long trace, you really need to go more native code, and that's what Quicktrace from Google does. That's really a low-level WebGL-based rendering tool for the big traces. So I think there's an argument to be made for both approaches. The thing is, if you have a standardized logging format, you can do both and share those tools much more easily than we have now. So, okay, thanks.
So I think one reason why implementations would actually work to provide this kind of unified debug output would be to be able to use like common tools that are available. And I think that might just be the biggest incentive, right? Because I think in the end, everybody will end up developing tools to debug their own implementations, and that can be avoided. That's
my point exactly. Yeah. But as a question, I just talked as well to the guys from Facebook, and they say we're still doing the text-based logging, text-based debugging, because we just don't have any manpower to make the tools. And to me, that says the tools are not important enough. The tools will not provide enough of a productivity increase versus what we're doing now to actually spend some time on it. Maybe I'm wrong about that assessment, but that's how it reads. So that's.
Have you taken this to the ITF at all?
No, I first wanted to gauge interest here, see if there is any interest at all, or if people are saying this is the worst idea ever, and then maybe I can start putting this forward on the mailing list or a draft or something like that.
I would very much encourage you to submit a draft.
All right,
And probably go to hackathons to your library.
I think that the concern that he brought up, that when bringing up the mailing list, that there will be more arguments about format rather than substance of the logging and stuff. It might, so we're definitely interested, and I think other implementations will also be interested. I think maybe just getting together and having a few implementations say that, okay, we're going to log in this format, and then take the idea of, hey, by the way, we have these awesome tools, and the compelling tools will automatically get people onto the format, because they're not going to, like you said, they don't have the manpower. Other people are not going to have the manpower either, so they might as well use the tools that have already been developed.
Okay.
Yeah. If you had a library, right, that was fast enough and easy enough and license friendly, that would be great, right?
Exactly.
That you can call from the right place in the implementation, and otherwise you don't need to really deal with the generation of whatever the format is.
Mm-hmm.
I think that would make it easy to integrate. The other thing is obviously you do want the really big guys on board, right? If you have Microsoft, Facebook, Google, the CDNs, some of them, right, that would probably give you critical marks, right? If you have Christian and me, probably not.
Yeah. I was hoping NGTCP2, since that's going to be reused a lot, I think.
True, but I still think the really big guys are also got to be ones you want, right? Especially if you're talking about wanting to diagnose somebody else's.
Yes.
Yeah, I like this idea. I think one of the challenges from having different endpoints is the coordination. You know, if I'm offering a service and the client says they have a problem, we have different logs, but even the ability to combine them, you know, is hard because they're in disparate formats. So it's not that even the analysis of those is hard in their own domain, but bringing those things together, trying to identify exactly where a problem might be, given that there might be middle boxes as well in the mix. So
Yeah, I like the ability and the flexibility here to be able to say the client will do that combination or the server will do that combination. Having an ability to stream that, I think would be really cool, because a client that's experiencing an issue could say, in some way, I want you to feed these things back to me. I'll combine a composite log that then I'll say, here, I was seeing some issues, images of the waterfall look weird, here's a log, and then that can be attached to an issue, and the service provider can investigate that.
Yep.
Okay, thanks again.
Thank you.